Okay, this lecture is going to be about renewable energy. So we're going to talk in particular about energy coming from biomass, hydroelectric power, solar energy, wind energy, geothermal energy, ocean energy, and then finally hydrogen fuel cells. The case study for this chapter is the nation of Iceland, which has set the goal of converting most of their transportation over to hydrogen fuel. They already get a lot of their electricity from geothermal energy and hydropower, and they have identified fossil fuels as a weak link in their economy and therefore have opted to try and get their transportation, including buses, cars, and ships, converted to hydrogen. Renewable energy is looked at as a source of energy that will not be exhausted, removes our dependency from fossil fuels, and creates more economic opportunities in the form of job creation. For the most part, the world is still powered by fossil fuels. Over 80% of our energy these days comes from oil, coal, and natural gas. In the U.S., in terms of renewable energy, the biggest source of energy is hydropower. That is the single largest form of renewable energy used in the United States. While in many other parts of the world, it may be biomass. Renewables are growing fast. They are growing faster than many other forms of energy. The fastest growing source of energy right now is wind power. It's expected in future years that this growth will continue, particularly with the decline in the supply of fossil fuels, especially petroleum. And this will happen even with very little government help. Compared to fossil fuels and nuclear energy, renewable energy receives very little subsidies from the government. Now, the first source of energy we're going to talk about is biomass. Biomass is a source of energy from formerly living material. Now, this differs from fossil fuels in that fossil fuels are dead organic material that were transformed through millions of years by heat and pressure into things like coal and oil and natural gas. However, biomass is usually the remains of living things like plants or their waste product or products produced from formerly living things like ethanol converted from the fermenting of sugars. One of the most well-known biomass is in fact the earliest fuel that humans ever used, and that is firewood. Over 1 billion people in the world today still use wood as their principal source of energy. In many developing nations, firewood is used for heating, cooking, and lighting their homes. And this is an example of a more modern way to use wood. This is a pellet stove where wood has been compressed into little pellets, giving a very high yield of energy per volume. Now, you might have heard a lot about the idea of using ethanol produced from corn. And in fact, if you go to most gas pumps, you will see that information on the pump telling you that the gasoline that you're pumping into your car has maybe 10 or 15% ethanol, and the remaining 85 or so is gasoline. In Brazil, they have switched over to more flex fuel cars. These run on a formulation known as E85, in which case it is actually 85% ethanol. And they produce ethanol by fermenting sugarcane. And that's worked really well in Brazil, which has a tropical climate. Ethanol grows very well there. However, sugarcane does not grow very well in most parts of the United States. About the only place where sugarcane can grow in the United States are the states of Florida and Hawaii. So there's not enough land area to produce sugarcane to meet our needs. But what about corn? You often hear a lot about converting corn into ethanol. Well, it turns out we could do that if we covered the entire surface area of the United States with corn, and then we could grow all that corn and use that as a fuel source. Unfortunately, that's not very practical either. But for that reason, researchers are looking at other sources of ethanol, not just the corn itself, but also what's known as cellulosic ethanol, ethanol that is produced from the stalks of the corn or from other high cellulose crop that can be grown like switchgrass. And it is believed that perhaps we could generate larger quantities of ethanol over a much shorter area using this source of cellulose instead of fermenting sugars. Another form of fuel that can be produced from vegetable material is biodiesel. This is often produced by converting vegetable oil such as cooking oil or grease or animal fat into this combustible liquid that runs pretty much exactly the way regular diesel runs. And it has the advantage that you can run a bus on this and your bus will smell like French fries, which I'm sure the McDonald's people will really love, as it'll give them free advertising. Biopower is the generation of electricity by burning biomass, and there's a number of ways in which that is done, such as growing waste products from numerous industries or vaporizing biomass into a procedure that will generate electricity, methanol, and diesel fuel. It is renewable if it's not over-harvested. It is carbon neutral, unlike fossil fuels, because we're not taking carbon that was trapped under the Earth's crust for millions of years, and we're taking carbon that's already being actively cycled. However, oftentimes, many of the biomass that we use are grown using tractors and other vehicles that are powered by fossil fuels. There are economic benefits, supporting rural communities, reducing our dependence on fossil fuel imports, and so on. So for this reason, you'll often see lots of support for the idea of something like ethanol produced from biomass, either corn or cellulosic ethanol. Drawbacks, it can generate indoor air pollution if used indoors for heating and cooking, can lead to all the problems associated with overuse of agriculture, and it also competes with food production. Many people argue that we are taking corn that could be used to feed starving people and using it as a fuel source. Hydroelectricity is electricity using the flow of water to generate electricity. Standard practice is to set up a dam that builds up a reservoir, and then using the water as it flows into the dam, usually from a high to a low point, the water builds up momentum as it flows through there, and then it hits our turbine, getting it rotating, and then generating electricity. That here is a schematic of a typical hydro turbo generator. Hydropower has some advantages over fossil fuels. It's renewable. So long as that river still flows, you can get electricity. And it doesn't generate air pollution like carbon dioxide. And it's also very efficient. It has an energy return on investment of 10 to 1. Remember, the energy return on investment of petroleum right now is only 5 to 1. So it is twice as efficient as petroleum is. There are some negative impacts, and we discussed some of these in the earlier chapter. Damming rivers, disrupting flooding cycles, sediment capture, thermal pollution, and the impact on aquatic life. It is widely used, however, in the United States, but it is not likely to expand for the simple reason that there are very few rivers throughout the world that don't have a dam in it that are suitable for a dam. So there's only so many places in the world you can build a Hoover Dam. Solar power is energy directly from the sun. There are a number of ways to do this. One example is what we call passive solar heating. It's a very simple thing. We use construction materials that will absorb, store, and release the heat. We can cause water to circulate through panels or use air flowing through panels to heat water or heat buildings that way. We can also focus the sun's rays to generate electricity. There are a number of ways to do that. One is using a power tower where mirrors reflect the sun's rays onto a central tower. And in this tower, the energy is collected and used to heat up some type of fluid. This fluid then can be used to boil water and generate electricity once it's really hot. And it can actually be stored, so this energy could be tapped in later during off-peak hours, for example, when the sun goes down. Another simple way of focusing the sun's rays is by a solar cooker, where mirrors are used to focus the sun's rays onto a source of food to cook it that way. And there's a solar dish engine. This is a similar thing to the power tower. These mirrors reflect the sun's rays onto this armature, and then that is in turn used to heat a fluid for use immediately to generate electricity or stored for later use. Another method is the use of solar troughs, where these curved mirrors focus the sun's rays on a fluid that is passing through a pipe here. And again, the fluid is heated up and then used as a source of energy. We can also generate electricity directly from the sun's rays through what are known as photovoltaic cells, or PV cells for short. These are made of a semiconducting material that, when struck with the sun's rays, electrons are knocked free and begin creating a current. Solar cells are widely used in a variety of things like pocket calculators. Many of you probably have a solar-powered calculator. PV cells are also widely used to power satellite because it's often easier to use these cells. All you have to do is tilt them towards the sun and you've got electricity than it is to, say, have batteries on board the satellite and have to send space shuttle up to change batteries, especially since we don't have a space shuttle. Solar power is growing fast. They are growing in developing nations where you can set up a portable solar array for an isolated village rather than hooking them up to a large grid for electricity. And in many cases, you can get what's known as net metering, where if you power your home off of a solar power array, you can not only free yourself from monthly electric bills, but if you generate more electricity than your home uses that month, you can sell the surplus electricity to the power company, so you get money back from them instead of paying them. Solar power has a number of benefits, as I said. It is very much renewable, since the sun will continue to burn for another 4 to 5 billion years. They use no fuels, they're quiet, safe, and require very little maintenance. Again, and like I said, they can allow for local decentralized control over power, which is very attractive in many developing nations and remote parts of the world. And they generate jobs and net metering, and they don't emit any pollutants while they're in operation. However, one drawback is simply that manufacturing them may consume fossil fuels and therefore generate some pollutants that way. As with the real estate maximum, location is key. Certain parts of the country simply receive more solar radiation than others. And in the United States, the best places to build solar power plants are in the southwest corner, although you can do some solar power usage anywhere in the world because there's always going to be some sunlight during the daylight hours. Solar power plants often have high upfront costs, but once they're in operation, they are very cheap to operate. The next topic of energy is the use of wind power, the fastest growing. This simply uses the force of moving air to push the blades on our wind turbine. In turn, then rotates our turbo generator to generate electricity. And once again, you can see some wind farms, as they're called, if you take the turnpike west towards Pittsburgh. And as you enter Somerset County, you will see a wind farm along the turnpike. And it is basically several of these wind turbines operating in conjunction with one another. And these things are huge. As you can see from this picture, they are gigantic in size, but they can generate a lot of electricity. Wind power is very fast growing. It is growing in many, many countries, including the United States, where California and Texas are the biggest producers. It is expected to continue to grow in the coming decades. By some estimates, it may meet 30% of our electrical needs by the year 2030. Another site that is looking attractive for building wind farms is offshore sites. Building them on the water, where you have less turbulence and more reliable wind speeds. Construction costs are higher, but they are offset by low maintenance costs, and the high, strong winds that have less turbulence could make them more profitable. Other places throughout the country that are attractive include mountaintops, which is where many of the places where they're looking to build wind power sites here in Pennsylvania. Benefits of wind power include no emissions, no pollutants at all, very efficient compared to other conventional power sources. The turbines use very little water. They can be scalable from one single turbine to hundreds, And farmers and ranchers can lease their lands, giving them an added source of revenue. And the cows just walk around the turbines. They don't care. They're cows. Downsides, simply that wind is often intermittent. We can't control where it blows. So there may be some days where you simply will get more wind power than others. The good places to build wind turbines are not always near population centers where the demand for electricity is. And oftentimes people complain about new wind farms for aesthetic reasons. I always asked, would you rather have these wind farms or a nice big coal burning plant belching smoke in the sky near your home? But another real concern about wind turbines is they do have an impact on a number of migratory bird populations as well as bat populations who may get injured by the rotating blades. And like solar power, it's often location that determines the best places to build them. But often you can see on land, at least, some of the best places are in the mountainous regions, like in the Rockies here and the Appalachian Mountains in the eastern part of the United States. And as I said, in Pennsylvania, the ridge tops on the mountains are often places that are targeted for setting up wind farms these days. Geothermal energy is tapping energy from underground. An easy way to do that is a place where you have a pocket of magma underground that is near a source of groundwater in the aquifer. This magma will heat up the water, boiling it, creating geysers like Old Faithful in the national park. As you might have noticed, one of the most important ways that we can generate electricity is through boiling water by burning a fuel or splitting the atom in the case of nuclear power so that we have steam to run our turbo generator. Well, geothermal energy basically says, well, here's steam coming out of the ground. But that's half the battle right there. Let's just put up a turbo generator that will capture some of that steam, run our turbo generator on that, then cool it off and re-inject the water back into the ground. It's renewable as long as that hot spot remains where it is. If it shifts, then it will no longer be viable. The other concern is it might deplete the aquifer. So some operators have begun injecting municipal wastewater into the ground to replenish the supply. It produces heat and electricity. It can be used not only to generate electricity, but also heat homes and buildings very cheaply, very efficiently. And once again, it's all about location. And some of the best places for geothermal are in the west and northwest regions. And sadly, south central Pennsylvania is actually a very poor place to have a geothermal power plant. Another way to get heat energy out of the ground are what are known as heat pumps. A geothermal ground source heat pump takes advantage of the fact that once you dig into the ground down to a certain depth, the temperature at that depth remains constant throughout the entire year. The heat that is in that layer doesn't escape and stays there, maintaining a fairly constant temperature. What this means is that layer underground is warmer than the surface is during the winter months, but then cooler than the surface in the summer months. So using a heat pump, all you do is move heat up and down. You draw heat up from that layer to warm the building in the winter months, and then transfer heat down to that level in the summer months as a source of air conditioning to cool the building off in the winter months. And this is a very efficient way to heat and cool a building, and is often widely used in a number of public buildings, including school buildings. Geothermal is growing at a lower rate, however, than hydropower and biomass is. It does provide more energy than solar and wind combined, though, and it is providing a huge amount of power. Japan, China, and the U.S. being the three largest consumers and producers of geothermal power. Benefits: reduced emissions, emits very small amount of gases. Limitations, though, may not be sustainable. The water pumped out of these things may be laced with salts and minerals that will corrode equipment and generate some pollutants, and it's limited to areas that actually have a hotspot where you can use it there. We can also tap energy from the ocean. We have constant movement of the tides flow in and the tides flow out. We have a place where we can set up a place where we can tap into that constant flow in and out of water. we can use that to run generators. One example is a wave energy source where we use the wave action as the waves flow in and then flow out, moving this ocean of water in and out to run our turbo generator that way. And then there's tidal power where we set up pylons or some other situations like this barge where we have propellers that can be rotated by the flow of tides. Again, the tides flow in and then they flow out, so we have net movement of water moving in and out in the bay, so we can use that motion to run our turbo generators that way. We can also take advantage of the difference in temperature. And this is a potential source of energy. It is still experimental, but it is a possibility if they could figure out how to make it more efficient. This is called ocean thermal energy conversion, or OTEC, and is based on the temperature gradient, the difference in temperature between the surface of the water and the lower deep water. So it's similar to a heat pump on land, but it uses the difference in temperature between the warm surface water and the cool, deeper water. It's very simply, you pull in cold water from the deep area and warm water from the surface, and then you take something that evaporates very quickly at low temperatures, like say ammonia. Use the warm water to evaporate the ammonia, and as it evaporates, you use the ammonia gas to run your turbo generator instead of steam, and then you bring it in contact with the cold, deep water by bringing the cold water up to the surface to recondense the ammonia. Now, this is still experimental and is not showing any potential for profiting. Now, finally, we have hydrogen fuel. Hydrogen is a great potential source of energy. It is highly combustible, burns readily with oxygen to generate large amounts of energy. So it is a potential energy source, and it is the most abundant element in the universe and is very plentiful on Earth. However, and this, the big drawback with hydrogen is the fact that it is not found freely. We don't have sources of hydrogen gas that we can just pump out of the ground like we pump natural gas. Most of the hydrogen on Earth is bound up in water molecules. So the first step in generating hydrogen as a fuel is some way to separate the hydrogen from the water molecule. So you break the water molecule apart, generate hydrogen and oxygen gas. One way to do that is through electrolysis, running an electric current through a measure of water to then separate hydrogen from oxygen. So in order to generate hydrogen gas, the first thing is we need some source of electricity. Now, in theory, we could use wind turbines or solar power arrays or some other renewable source of electricity to then produce hydrogen gas out of seawater. One of the advantages of hydrogen is when it combusts, when it reacts with oxygen, the waste product is water. So we take water, separate hydrogen out of the water molecule, breaking it away, freeing it from the oxygen atoms, and then when we react the hydrogen gas with oxygen once again, we get water back again. So potentially it's renewable because we start with water and we end with water. We can obtain hydrogen from other sources. We could do electrolysis on methane. The problem with methane production of hydrogen is right here. Our waste product is carbon dioxide, and that's what we're trying to avoid here. We're trying to remove sources of carbon dioxide emissions, so this is not considered a green and environmentally friendly way to generate hydrogen gas. Now, one of the things that excites people about using hydrogen is that we can use it in what's called a fuel cell. A fuel cell works kind of similar to a battery, and it generates an electric current by reacting hydrogen with oxygen, but it's not burning the oxygen. Instead, the hydrogen fuel enters this side of the battery. The electrons are separated from the hydrogen molecules, and these then travel along the wires to make our current. Meanwhile, the hydrogen ions, these are positively charged, they travel through the membrane where they meet up with oxygen atoms and those same electrons as they zap through the wires to ultimately form water as our waste product. So we can get oxygen from the air, and all we need is hydrogen, pump that through the fuel cell, and we can generate an electric current. And this could be used, for example, to power transportation in vehicles. This is an example of a fuel cell bus where we have hydrogen fuel tanks. This is then pumped through the fuel cells to generate electricity to run our motor, and then our waste product is water vapor. So that's a very clean source of energy. Benefits and drawbacks to hydrogen, though. One thing, we have a lack of infrastructure. We would need to build nearly as many hydrogen fueling stations as we have gas stations in the U.S. today. Vehicles would have to have sources where they could refuel hydrogen, like I said, just the way they refuel gasoline when they are driving down the highway. There is concern that hydrogen leakage could impact stratospheric ozone if it gets up that high. But the benefits, it's unlimited, clean, non-toxic, very few greenhouse gases. As a combustible material, it's no more dangerous than gasoline. And the cells are efficient, silent, and non-polluting. And again, all we need is the infrastructure to build up the hydrogen. Another way we can generate hydrogen is biologically. There are certain species of algae that actually, under certain conditions, if you starve them of oxygen for a while, they will switch to a different form of photosynthesis that generates hydrogen gas. So in theory, we could breed large vats of algae and then just encourage them to keep producing hydrogen. So if we could make this efficient, we could generate that as a source of energy. And that concludes the lecture on renewable energy.